Rocket can mean different things in different contexts. Simply put, a rocket is a spacecraft, missile, aircraft, or other vehicle that obtains thrust from a rocket engine. From the outside, the frame of a rocket is very similar to that of an airplane. It's made of various light but very strong materials, like aluminum and titanium. The skin of the rocket is covered with a thermal protection system that protects the rocket from extreme heat caused by air friction and helps maintain cold temperatures that are needed for certain fuels and oxidizers within the rocket. The body of a rocket is composed of different sections, all of which are housed within the frame of the rocket. The first component is the payload system of the rocket. For the uninitiated, the payload is the rocket's carrying capacity. The payload depends on the type of mission the rocket is being used for. It can consist of cargo, a satellite, a space probe, and even a spacecraft carrying humans. So, if you want to send humans to space, the payload of your rocket will contain a spacecraft. Whereas if you're using the rocket as a weapon, then the payload would consist of a missile. Next is the guidance system. The system which ensures that the rocket stays on its intended trajectory and goes where it's supposed to go. The guidance system consists of onboard computers and sophisticated sensors, as well as radar and communication systems to maneuver the rocket while in flight. Last is the propulsion system. A majority of the entire length of a modern rocket is actually made up of the propulsion system. As the name suggests, the propulsion system consists of the components that help launch the rocket off the ground and subsequently propel the rocket in a given direction. So how is this huge, enormously heavy cylindrical metallic tube shot into space? In order to get into space, the rocket must first cross the thick layers of atmosphere that envelop our planet. Since the atmosphere is thickest near the ground, the rocket has to go extremely fast in order to get past this part of the atmosphere. So how does it climb so fast in the air? The answer to this question lies in one of the most popular physical laws of the universe, Newton's third law of motion. According to the third law, every action has an equal and opposite reaction. In our case, we have a rocket that we want to launch into space. How does the third law help us? That's where the rocket engine comes into play. A rocket engine works by burning either a liquid or solid fuel in the presence of an oxidizer. When the combustion reaction occurs, it throws out a great deal of mass as a byproduct of the reaction. These byproducts are released at great speed through the bell-shaped nozzles that you see at the bottom of rockets. Since the rocket pushes the exhaust down, the exhaust responds by pushing the rocket up at great speeds, which lifts the rocket off the launching pad and propels it upwards into space. In a way, you could say that a rocket shoots upward by throwing hot gases from its exhaust nozzles below. If you have ever seen a rocket launch in person, or even seen a rocket launch video on the internet beyond the liftoff phase, you may have noticed that a rocket doesn't maintain a straight trajectory all the way up. It lifts off perfectly vertically, but at around the 1 minute mark of the flight, it starts turning and going laterally. That is a flight maneuver known as the gravity turn. It's a trajectory optimization technique that's always employed while launching rockets because it offers two benefits. First, it uses gravity to steer the rocket onto its desired trajectory, which helps to save rocket fuel. Second, it helps to minimize aerodynamic stress on the launch vehicle. If a rocket continued going up without tilting at all, it would reach a point where it would run out of fuel. That's why it tilts slightly after lifting off straight up, thanks to the exhaust nozzles of the rocket, which can be swiveled from side to side in order to alter the direction of the thrust. Once a rocket lifts off, parts of it are sequentially separated or jettisoned at predefined intervals. For instance, if a spacecraft is being launched with a rocket, then its rocket boosters are separated first, followed by the external tank. These separated parts blast off from the spacecraft and splash down in the Atlantic Ocean, where they can be retrieved. The spacecraft then maneuvers on its own using its main engines to reach the desired orbit. Similarly, if an unmanned satellite is launched on a rocket, the sole purpose of the rocket is to get the satellite into its intended orbit. Once there, the satellite stays in the orbit and does a small amount of maneuvering using its own engines. All in all, rockets are used only to get stuff into space, period. Once a rocket has done its job, it's separated, in parts, from the stuff that it carries, as it's no longer considered an operational requirement of the mission. Space agencies all over the world have been sending men and material into space for decades now. As such, It's only fair to say that we wouldn't have been able to understand and explore space nearly as much as we have, if not for those tall, cylindrical, metallic tubes that shoot up from the ground in a bid to expand man's reach beyond this planet.
Okay, then I hope that you understand something from this video. Now I will find one more video for you. You may check it and check the car safety procedure or the car safety rule. Okay, then we will talk about both of them one by one. This video is not very long, this is just a very short video, then we will talk.
Seat belts continue to be a highly effective safety technology and have saved countless lives in vehicle collisions over the years. But recent advancements have resulted in more sophisticated seatbelt technology that enhances occupant protection while helping reduce injury from the system itself. Pretensioners automatically retract the seatbelt and secure the occupant instantly during severe deceleration, such as that caused by a frontal collision. The aim is to control occupant movement within the cabin space while ensuring that the belts are comfortable in everyday use. To avoid injury to the occupant by the seatbelts themselves, force limiter systems are used. Force limiters come into play when seatbelt pressures applied to the occupant reach a predetermined level. At that point, the limiter allows the belt to extend to help reduce the impact on the occupant's chest. In a serious collision where the SRS airbag may deploy, the pretensioner activates with the airbag after a signal is received from the SRS sensor assembly. After deployment, the force limiter also comes into play as an added method of protection, reducing the load applied by the seatbelt to the occupant's chest. Combined, these systems help the front airbag deploy more effectively during a frontal collision. As an added safety step for vehicles equipped with adjustable height seatbelts, they should be adjusted correctly for occupants of different heights to maximize safety. The features and functions described in this video might not be applicable to your Toyota model. See your owner's manual for details. Thanks for watching this Know Your Toyota video.
Okay, so we will talk about both of them. So before that, let me ask you one more question. Do you know how far are the satellites from the Earth? In which layer the satellites are moving around the Earth? Have you ever thought about this? And for example, now we have thousands of the satellites and they are moving around the Earth. And how much far they are from the Earth and in which layer they are moving. Okay, so let me show you one picture, then you may check here. Okay, see that here we have how many layers? Yes, over the clouds, yes, but we have different layers and you can check. For example, this is the Earth. Now see that the airplane is moving then lower than 20 kilometers. Okay, lower than 20 kilometers a day. For example, the airplanes and especially the helicopters and other airplanes are moving here. So this is called what? Troposphere. Troposphere is the nearest layer of the Earth and the atmosphere, and it is around the Earth. And next one, we have some balloons, and those balloons are moving, for example, stratosphere, and this is called lower than what? 50 kilometers. And then we have mesosphere, and then it is under the 85 kilometers. And atmosphere is around, for example, around 100 kilometers. Okay, so less than 100 kilometers is called what? Atmosphere. but over that one we do not have any gases. We do not have what? We do not have atmosphere. So over than this one we have, for example, 4 satellites. Okay, thermosphere is under 690 kilometers. So the satellites and the this one, the space satellites, and they are moving around the earth. It is about 10,000 kilometers away from the earth. So this is the question. For example, when we want to send a satellite or a rocket from the earth to 10,000 kilometers away from the earth, and then we let those rockets to move around the earth, it takes how much time, how much energy to do it, to escape from the earth gravity from this point till this point. Okay, so that's why we need a lot of energies, and we need the energy that take one rocket from the earth to 10,000 kilometers away and do it to escape from the gravity of the earth. So that's why today we will talk about this question, that what makes the rocket to produce energy or to move to escape from the gravity first. This is the question. Yes, if there is any question, yes, Miss Fatima Nazari, do you have anything to say?
Yes, sir. Could you please send the link of the videos in the group as well?
Yeah, here I have written just exactly here. You may just check. Here I have written the name of those videos. This is the first one is the video of the car safety driving, and the second one is for the rocket, how rocket works on this one. You may exactly copy and paste this one in YouTube. You can exactly find the first video. You can see this one. Okay, here is the link, the name of those videos.
Okay, sir. Thank you.
Yeah, welcome. Ms. Mursal Amiri, you may continue. Open your mic.
Yes, sir. Actually, what you explained earlier on the photo, because I lost my connection.
Should I send the picture as well in your WhatsApp group? I didn't understand actually. What did you say, and what do you mean by this one? So I have this different pictures for example, for satellites and for the orbit around the earth, how much distance do we have, and different parts of the earth as well here. Should I send them to you in WhatsApp group or in Google Classroom?
Okay, sir. Just send it. I will check it myself.
Okay, because some of these pictures are not visible, so I found just only one that was visible to be checked. Okay, so let's start from this point. Yeah, today first we will talk about the momentum again. We will talk about the conservation of momentum. Then we will talk about the process of movement in rockets, and next one we will talk about the car safety, one by one about all of them. First, so let's continue together. The core principle or the main principle of conservation of momentum is that the total amount of momentum before the accident is equal to the amount of momentum after the accident. Exactly about this this process, yesterday we solved some problems, some questions, and some equations. Okay, so we found that exactly before the accident and after the accident the amount of momentum is equal. But there was one condition. What was the condition? That we should consider this system in a closed system, not open system. Because when we take out something in the open system we have a lot of external forces, for example gravity, for example the friction force, and for example the air resistance. So when we have a lot of for example external forces, so they may affect on the body, and they of course they will not have the result that we expect, but we think our system as closed. Practically we think that one, okay, but not actually it is like this one. Next one is rethinking about explosion. Rethinking about explosion, what does it mean? For example, when we have explosion, especially it happens in the rocket. So how exactly this explosion helps the rocket to move forward? And this is called, for example, explosion. We have two main definitions for explosion. One is daily explosion, so the things that which produces a lot of fire, we can call them explosion. But in physics, this explosion is completely different, okay? So this explosion in the physics will mean that when something burn and produce what? Energy. Sudden production of the energy is called what? Explosion. But how can we control this amount of energy production, and how can we control it, and how can we direct it? For example, in which direction we should produce this energy, and how to use from this energy. This is called what? Explosion. Now let's come and explain the explosion in the rocket. Here we have a rocket, and this rocket use the energy which is produced by explosion and move from the earth to the sky or space. As you saw the video, now I want to ask you how the rocket move forwards or leave the ground, the earth, with this much gravitational force and escape from the gravitational force. Now I am asking you, as you saw the video, now how this action happens? Can you say something about this? For example, how the rocket escape from the ground and move upward. Okay, anything, if you have anything that you can add, for example, no problem that if you think that's right or wrong, or even yes, by the energy production, yes, that's correct. By the fuels, so fuels explode and fuels burn inside the for example inside the rocket, and they produce the energy. But how this energy production can cause the rocket to move upward? This is the main question. Yes, Ms. Fatima, you may continue. Ms. Mursala, you may continue.
I think that it burn fuel and just go upward. That big that create that the rocket move upward. I mean, the fuel make it.
The fuel make it, and production. This one, the rocket may when the fuel burns inside the rocket, so they produce a lot of energies, and they produce pressure, and then they make the rocket to move upward. Okay, anyone else? Okay, so that's okay. If you cannot explain, I am sure that you all have enough information, but if you cannot explain in English, you may explain in Persian. Okay, so think and manage your information, arrange it, and explain how the rocket move from the earth to the space. No one else? Okay, so let's continue from this part. In the rocket, we have, dear students, we have one system, and the name of that system is exhaust. or we call them what? Exhaustion system. Exhaustion, let me to write this one. Exhaustion system. Exhaustion system. Exhaustion system. So they have what? For example, in one part of the rocket, it has what? Chemical substance. Chemical substance. And this chemical substance do it? Burn. And when they burn, they produce energy. They produce energy. So till here you all know that yes, for example, if we have fuel, this fuel is a chemical substance, and when we burn the fuel, so the fuel produce a lot of energy. But how this energy make or causes this for example, this rocket to move forward? For example, we have a small box here. We have a small box, and when the fuels come here, exactly, for example, you may think this box as a machine. When the fuels come inside this machine, we do have what? For example, here we have ignition system. Ignition system. Ignition system. And this ignition system produce what? Fire. And this fire make this fuel to do what? To burn. To burn. When they burn, so this action produce a lot of energy. So this energy do what? Now we have a lot of energy inside this box, and we have a small hole in backside. Okay, a small hole exactly in here, a very small hole. Now all this energy tries to do what? To get out of this hole. Get out of this hole, because we have a lot of energies inside this box, and this energy tries to get out of this box, and there is no other parts that they can escape and they can get out of this box, but there is a small hole. For example, this is the small hole that they can leave. This one, they can leave the, for example, the box, and then when they try to leave this one, so they force the rocket upward, and they leave for example, the rocket, and they come downward. So here this is the exactly calculation of what? Moment, and the action of the role of Newton, action and reaction. Action and reaction. So action and reaction, this is the law of the Newton, the third law of the Newton. So what does it mean by action and reaction? Action and reaction means that when they force to come out, okay, so the exact force will be produced to make the object to move what? To move upward. So that's why when we use when the energy produced in here, so this energy tries to come out of the rocket, and the exact amount of the rocket, for example, the energy come out, and the reaction will be what? The equal amount, and cause the rocket to move upward. So this is the role of action and reaction, and the amount of moment that this rocket will produce. I hope that you understand something from this part. If you have any question, any problem in this point, then you can ask. As we saw exactly inside the rocket in the video as well. So if you didn't understand here, then you can watch the videos many times, then you can come back here in this video, in this slide, then you can exactly understand that the effect of action and reaction can cause the
so you mean that the exhaustion system?
Yes, you may continue.
So actually you mean that the fuel, exhaustion system, energy, and also chemical substance all cause the rocket to move upward?
Yes, the exhaustion system is the only system that they produce energy. But how this energy cause the rocket to move upward is this one, that we have a small hole, and this hole, when the energy, the heat or the energy which is produced inside the exhaustion system, and when they tries to leave this, for example, box, so they do what? They do produce a lot of energy, and they come what? Out. And when they come out, they force the air, and when they force the air, the action is downward, but the reaction is upward. So we have two, action and reaction. The reaction can cause the object to move upward. Okay, so now come to the next part of our slide. Here we have the rocket, and this rocket may move upward, and we have this system. Now let's see that combustion chamber. Okay, so here we have a small box. Okay, so the energy may burn in this box, and this box produce what? Produce energy. The energy will be produced in this box, okay, where the controlled explosion occurs and releasing massive energy. In this box, a lot of or a massive energy will be produced. And exhaust nozzles means that the action force and high speed exhausting gas are forced out and creating immense downward momentum. Okay, so here we have a small hole exactly in this position. Okay, and this hole control what? Control the amount of energy released. Okay, come out. And for example, if too much energy comes out at the first, for example, this rocket may move very fast for a short time, because the energy will be expended. So when we spend a lot of energy in the short term, so the rocket cannot leave the ground properly. So that's why here we have a nozzle. Nozzle means that they control the amount of energy which is released in the down. When they move down, so they produce what? Momentum in here in the downward. And next one, rocket body reaction force the mass of the spacecraft accelerate upward into the space. So this, the body will move what? Upward, because of the reaction. Because of the reaction in upwards. But it has a lot of problem, and when we make like this one, so of course that we should force and we should calculate a lot of information about this one. Okay, now from this sky that we as we calculated the momentum on this one in the previous examples, now come to the car, how momentum will affect the car. Okay, so this is the next problem, and we should talk about the car safety. Car safety is a little bit interesting. Now come to here. When a car have a collision, when a car has a collision on something, there are some very important factors that they have. For example, first, when we have a car accident, so there is the relationship between the force and the momentum and the time. Here we have these three factors. They are very important when we have what? Car accident. The first one is force. For example, when we have car accident, there will be the force will be produced, and the time is also very important, and the momentum is also very important. So how to calculate and to make for example, understand that, yeah, how much time is very important, and which factor is very important to save the life of the passengers or drivers. Here we have one structure here. First, Amount of time is very important in car accident, in car collisions. For example, if we have a small amount of force at this one time, we will have what? We will have a lot of force. So here we have this one, the relationship or the proportionality about the time and the force. If we have long time, then we will have less force, and if we have short time, we will have too much force. So the relationship between the time and the force is indirect. So we will count this one by the formula, okay? Increase in the time, decrease in the force. But here we think that if we have a large amount of time for car accident, then we will have a small amount of what? Force. So that's why today we will count about this one, how the force and how the time effect on the car accident, and how do we control that, how can we produce more time for the passengers to save their lives. Here is some points that we can use. For example, what is the first thing that we can save the life of passengers? This is the first one is seatbelt. Next one is crumple zone. I will explain what is exactly the meaning of crumple zone. And skipping lane. Skipping lanes is the short distance that we can, for example, we may have before the car accident. So I will explain all of them step by step. First, let's talk about the seatbelt. As you saw in the video, seatbelt can decrease the amount of what? The amount of force which will happen after the car accident. And as you saw that if we wear the seatbelt, so the seatbelts can help us to produce longer time. When we produce the longer time, so this longer time causes that we have, or we may produce less force, okay? So if we have a short time, then the short time may causes what? A lot of forces that then we will count in the example, we will check here. Okay, next one, let's see here. What is the meaning of crumple zone? For example, here, this part of the car. Now see that after the car crashed, then this part of the car is completely destroyed. So why don't the companies make this part of the car very strong, not to be destroyed? Is there any reason behind this one, and they do not intentionally make this part of the car strong? Can you explain why? For example,
I think
yes, the front part of this car, they intentionally do not make this part very strong and make this part of the car very weak. When the car crash with another one, so they will be destroyed. And if you can explain why, then we will understand that this is called what? Crumple zone. Yes, you may.
actually I think I think that because sometimes if the force is so strong that could not be damaged, so it is the main part of the car.
So what is the benefit of damaging this part of the car for drivers and for passengers?
Can you repeat your question again, sir?
I mean that, for example, if we make this part of the car very strong, okay, not to be destroyed during the accident, we can make it, okay. The factories can make this part of the car very strong. Even after the accident, there will be no damage. Okay, so what is the benefit of damaging this part for the passengers or for drivers? Is there any benefit for the drivers and passengers or no for destroying this part of the car?
خب اصلا من فکر کنم چون که این بخش کار خیلی چی جور میکنن به خاطر اینکه وقتی که اگر در کلام جایی تصادم کنن اول که پسنجر همون کسی که درایور هسته همون درست میکنم مثلا قرار سلامه نبینه دیگه این بخشی مهم از کار است که بخشی است که تمام چیزای کار در اونجا تمام چیزای موتر در اونجا بند است و اگر خیلی تصادم قوی باشه باعث انفجار شد یعنی موتر در بگیر.
Okay, so now see that, yeah, as you explained, this is exactly right. The companies intentionally do not make this part of the car strong. Why? Because they do what? They produce more time. How? For example, if we make this part of the car very strong, so the car will be stopped, for example, in 0.02 second. Okay, but if we do not make this part of the car very strong, so the car, for example, this part of the car will be destroyed and then come to this part, so it takes longer time for the car to be stopped. For example, in the first condition, the car will be stopped after 0.002 second. But if we do not make this part of the car very strong, so the car may stop, for example, after 0.2 second. Even most of the time, the cars can be stopped, for example, 0.2 second. Okay, so let's count for both of them, for all of this one. And if the car stopped, for example, after 0.002 second, how much force will be produced? And if the car stops after 0.02 second, how much force will be produced? And finally, if the car stops 0.2 second, after 0.2 second, how much force will be produced? We will count exactly and we will see that how much is the difference between these three conditions. Okay, for example, if we have the car very strong, after how much time the car will be stopped? Okay, 0. So this is the strongest types of accident, and there will be no chance for the driver to stay alive. The drivers will die. Okay, so we will see this now, and we will count that, yeah, if the car stops after 0.1 second, and then if the car stops after 0.2 seconds. Okay, so we will have one example and then we will count it. Here is the example. Okay, here we have one scenario and then we will count one by one. For example, calculate the force exerted or inserted in a 50 kgs passenger. Okay, so the passenger, we have one passenger inside the car, and the mass of that passenger is how much? 50 kgs, 50 kilogram. And in a car traveling at which velocity? The velocity of this car is 20 meter per second. This is the velocity. The 20 meter per second that suddenly crash and stop completely in 0.02 seconds. Okay, so one car crash may happen, and only how much is the time? The time will be 0.02 second. So let's do what? Let's find how much force will be produced if the car stops after only 0.02 seconds. Okay, here we have all the points that which is given to the example. Okay, now you have everything. For example, you have the mass is 50 kgs. Yes, the mass of the passengers. Initial velocity, the first velocity that we have, it is 20 meter per second. Final velocity, it means that the velocity after the car accident. So of course that the car will be stopped, the final velocity will be 0. Stopping time that the car will be stopped is equal to how much? 0.02 second. Now let's calculate and let's find the momentum and let's find the force, how much force will be produced. Okay, so come to here. As we saw that, for example, the first formula which I gave you is equal to how much? Delta P, F is equal to delta P over T. and then you can find like this one. Delta P means the differentiating between the what? Differences between the momentum. Okay, mv means that mass multiplied by final velocity minus mass multiplied by initial velocity. Okay, so let's see. We have the time here. So let's put all the numbers here. Okay, so here I think that the number is taken wrong. For example, the initial velocity, here we have the final velocity is equal to 0, but here we have initial. The initial velocity is 20. Just replace here. Okay, for example, here we have the mass is 50 kgs times 0, because the final velocity, as I gave you in the first example, here the final velocity will be what? 0. And next one, here we should put minus, then mass is 50 kgs, and how much is the speed or the velocity? It is 20, and we have 0.02 second in here. So let's count it. How much will be the force? The force will be equal to, okay, 50 times 0 will be 0, minus 50 times 20 will be 1000. Okay, so 1000 over 0.02. I do not have calculator, so you may count it. As we can see that the result is already counted here. How much is the result? Okay, see that this object, if the car, for example, stops at 0.02 second, so 50,000 newtons force will be produced only by what? By the passengers here. Okay, so let's come to the example. For example, here we have the passengers. The passenger is in the car. Okay, for example, this is the passenger, and if the car crash at this velocity and with the mass of 50 kgs, okay, so this is the 50 kgs of the passenger. How much force only this passenger may produce? 50,000 newtons. Now see that how much force is this one by this one. Okay, so here is my question. You may do this question. Okay, 1 minute. Let me to answer these questions with next example. Okay, for example, P is equal to mv or delta P. Let's count with another formula. Okay, so here delta P is equal to, how much is m? M is 50. How much is velocity? Velocity is 20. So delta P or the momentum is how much? For example, 1000 kgs meter per second. So now if you use this formula, delta P over T, force is unknown, so we should find how. For example, this is, we have 10,000 yes, over 0.02, so the force will be equal to the same, 50,000 newtons. Okay, so here is my question. You may do the same question, answer the same question for the time, little break the changes in the time. Okay, so here we had 0.02 second. Now you may count it with 0.2 second. 0.2 second. You may solve this question and tell me the answer. How much will be the force which will be produced by 50 kgs of the mass if we have, for example, if the car stops after 0.2 second. Okay, do answer and then give me the result that you will achieve it.